Welcome back again. Today we are going to be working on combining like terms. You're going to need notes 00, which is your Unit 2 vocabulary, as well as notes 9, which is our combining like terms notes. Let's start with a little bit of vocabulary. So, like terms, what are they? They're terms that have the same variable and exponent. So some examples, 3x and negative 2x, they have the same variable and they have the same exponent. If there's no exponent listed, there's an imaginary 1 as the exponent. Same thing with y and 4y. There's a same variable. They have the same exponent. This could be written as 1y as well. Excuse me. There's two more vocabulary words I'd like you to write down. You can write these on the back of your sheet. They're not already on your notes. An algebraic expression is a combination of symbols containing one or more variables, numbers, and operations. So an example could be 2w plus 6 or x minus 5. Finally, simplest form. When an expression has no like terms and no parentheses remaining, we know that our expression is in simplest form. You can use the same example for both algebraic expression and simplest form. Pause the video and write down these three vocabulary words. So let's talk more about like terms. Like terms are terms that have exactly the same variables, and those variables have exactly the same exponents, and we can only combine like terms. If you haven't put a 9 in the upper right-hand corner of your notes, go ahead and do so. Unlike terms don't have the same variables and exponents. So let's do some examples. Like terms. Let's go through each one here. 3x and negative 2x. You saw in the vocabulary, they have the same variable, x, and the same exponent, 1. So they're like terms. The next example, we both have x, and that x is squared. Same variable, same exponent. The coefficients don't matter. It doesn't matter if it's negative and positive. That part doesn't matter. Just the variable and exponent. Same thing here. X to the first, y to the first, x to the first, y to the first. Those are the same variables, same exponents. So we have like terms. And in our last two examples here, this term has x squared, this term has x squared. Let's make a quick note. That little 2 says squared. Let's use that instead of saying to the power of 2. And this term has y cubed. So the little 3, instead of saying to the power of 3, we're going to say cubed. Now here in our last example, we have xxy and x squared y. Well, how many x's are here? There's 2. So xx is really the same as x squared y. So these are in fact the exact same term. So now let's take some look at some examples of unlike terms, and let's write down why they're unlike. So in our first example, 8x and 7y, they have different variables. What do you think the problem is with 5y and 5y squared? What's the exponent on the 5y? It's that imaginary 1. So they have the same variable. Do they have the same exponent? They don't. So we have different exponents. 4y and 5xy, they both have a y, but this one has an x. So different variables again. What do you think the problem is with 3x squared y and 2xy squared? I see x's, y's, and squared. Did you think about that? The squared is on a different variable. So the exponent is on different variables. Has to be on the same variable if they're going to be like terms. And then finally down here, remember xx was x squared y. And this one we have 1x and 2 y's. So again, same issue. The exponent is on different variables. Let's have you try some. So we're going to look at each pair and we're going to decide if these terms are like or unlike. And we're just going to write like or unlike below each pair. So let's start here. 3x squared and 4xx. Well, we would rewrite 4xx as 4x squared. So do we have the same variable? Yes. The same exponent? Yes. So these are like terms. You try 2a cubed and 5a cubed. Are those like terms or unlike terms? Did you say like terms? You'd be correct. How about 4x and 7y? Unlike, right? Because we have different variables. 6x squared and 2x cubed. Unlike as well. Good job. Different exponents. 3xy and 2yx. This one's a little bit tricky. So first we're going to check, do they have the same variables? X and x, y and y. They do. Are the exponents on all those variables the same? They are. So the order doesn't matter. So these would be like terms. How about 7c and 7? Do they have the same variable? No, 7 is a constant in this case. And since it doesn't have a variable, they're unlike. How about 5 and negative 13? Do they have the same variable? Sort of. They both have no variable. So does that make them like terms? It does. You try the next one. Did you say like? Good job. Right? Because this is 3x squared y. 4x and negative 4x. Does it matter that one's positive and one's negative? Nope. All that matters is they have the same variable, x, and the same exponent, 1. So these are like. How are you doing so far? Try this one. Now let's go to the back page and work on actually combining our like terms. So now we've determined how we can decipher whether we have like terms, and now we're going to combine them together. So when you combine like terms, you're always just only adding and subtracting. So you're only adding and subtracting the coefficients. Remember, the coefficient is the number in front of a variable or being multiplied by a variable. And the variable and exponent will just come down with it. So in this example, 2y squared plus 8y squared. They're like terms because they have both y's and they're squared. And so we're just going to add. 2 plus 8 is 10. The y squared comes with it. So let's try a couple. 5x plus 2x. Are they like terms? Yes, same variable, same exponent. So we're just going to add the coefficients and bring down the variable. B, 7y cubed minus 3y cubed. Are they like terms? Yes. So we're just going to perform the operation. 7 minus 3 is 4, and the y cubed just comes with it. How about C, y cubed minus 7y? How would that simplify? This is in simplest form because these are unlike terms, so we can't do anything else. So often you're going to have expressions with multiple terms. And so what you're going to need to do is identify the like terms and then combine those like terms to simplify. I like to use shapes and colors to identify my like terms. So as you can see here in the example, we have 5a plus 3b minus 4c plus 2a minus 5b. And so I went through and I circled all the a terms in blue, all the b terms in green, and I didn't have any other c terms. Notice that in the circles and in the squares, the sign that's attached to the term is also in that circle or square. And so we're just going to combine the blue circles. 5a and 2a is 7a right here. Positive 3b and negative 5b is negative 2b. And then the negative 4c just comes over. And this answer is in simplest form because there are no like terms anywhere longer. Let's try the next one. So we have 9x squared. Which term is a like term with 9x squared? 4x squared. Good. So 9x squared plus 4x squared, 9 plus 4, 13x squared. And then we have our constants, 10 and negative 7. Positive 10 minus 7 is positive 3. Do we still have like terms? We don't. So we are now in simplest form. Let's try one more. So we have our x squared terms. 3x squared plus 8x squared is 11x squared. Then we'll have our x terms. 4x, 7x. And since they're both the same sign, we add, keep the sign, bring down the variable. And then we have the constants, -5 and +2. Different sign, subtract, keep the sign of the higher number, -3. Are there any like terms here in 11x squared plus 11x minus 3? The answer is no. We're in simplest form and we're done. Why don't you try number 1? Use shapes or colors. Just to return to the example that we did above just for a second, notice that when I write my simplest form answers, if there's multiple variables, I list them in alphabetical order. And if there's not different variables, we list them with the highest exponent first, then the next lowest, and the constant last. So highest exponent first, constant last. And so we're going in descending value of exponent. All right. You try number 2 as well. See what you get. Let's try number 3. So our like terms, -2 and 1/10 r, -17 r. Same sign or different sign? Same sign. So we're going to add and keep the sign. So remember, in the number 17, the decimal's behind it. We want to line up our decimals, and we're going to add. Same sign, add and keep the sign. So I have -19 and 1/10 r. And since there's no like term with this 5 constant, it's a positive, so +5, and we are in simplest form. Let's try number 4. So we're going to start with the highest exponent term, 6p squared minus 10p squared. Same sign or different sign? Different sign. So we're going to subtract and keep the sign of the higher number. Remember, in the number 10, the decimal is behind it. We want to make sure that we line up our decimals when we are subtracting. We're going to borrow. 10 minus 4 is 6. Decimal comes straight down. 9 minus 6 is 3. Subtract, keep the sign of the higher number. Which one would be higher? The -10 is higher, so we're going to keep its sign. So we have -3 and 6/10 p squared. And then we have our p terms, where p is to the first power, right? That imaginary one. And these are same sign. So same sign, add and keep the sign. So we're going to add 7 and 14. Keep the sign is going to make it negative. We have -21p. We have no more like terms, so we are in simplest form. You try number 5. See what you remember about those fractions from last chapter. Make sure you fully simplify. One more example. So if we look at number 6, we want to start with the highest exponent term. So that's my 4n squared. Are there any other like terms with that? There aren't. So it's just going to come down as you see it. Then I'm going to go to my next lowest exponent, my n term, because this is that imaginary one. Are there any other terms that are like terms with -2n? No, I don't see any others. So that one's just going to come down as well. So then we have 2/3 and -9. Those are both constants, right? A fraction is a constant, an integer is a constant. It doesn't matter. So we have 2/3 minus 9, or -9 minus 2/3. Sorry, plus 2/3. That 2/3 is positive. So we need a common denominator. What would that common denominator be? It would be 3. So we're going to multiply -9 by 3 to get -27/3, and -27/3 plus 2/3 is negative 25 thirds. And we'll convert that back to a mixed number to make it a little bit more palatable. How many times does 3 go into 25? 8 times. 8 times 3 is 24. That's 1 away from 25. The denominator would be 3, and the sign would be negative. And there we have simplest form again. Now it's your job to put on your thinking cap. Take a look at the problem at the bottom. Find and explain the error. So here's this problem, 2m plus 3m squared plus 6m. And this person wrote 11m cubed. I want you to figure out what this mistake was. What did this person do wrong? And then I want you to work it out correctly in this space over here and figure out what the correct simplified form would be. See how you do. Did you get it? Great job. We're going to keep working on combining those like terms. See you next time.